Docker is an open source platform that has revolutionized the software development process by introducing the concept of containerization. It enables developers to package applications along with their dependencies into a standardized unit for software development. This unit, known as a Docker container, can be shared, deployed, and run consistently across various environments. Now, why Docker? Docker's significance lies in its ability to simplify and accelerate the application development lifecycle. By packaging applications and their dependencies into containers, Docker ensures that the software will operate uniformly, regardless of the underlying infrastructure. This consistency eliminates the typical "it works on my machine" problem, smoothing the path from development to production. Now, let's compare Docker with the traditional virtual machines. While both Docker and traditional virtual machines, also known as VMs, provide an isolated environment to run applications, they function differently. For example, Docker containers are lightweight as they share the host system kernel and utilize its resources directly. This leads to rapid startup times and less computation overhead compared to virtual machines, which they need to boot up an entire operating system for each instance. For example, let's imagine we need a database. We can either install it on a new virtual machine, Windows machine, or Ubuntu machine. It will boot up and we are gonna install there PostgreSQL. Now, PostgreSQL will take an amount of RAM, but also the virtual machine can take 2, 3, 4 gigabits only for starting the operating system. If we take in consideration to use a container for this, we can have this situation. In a list of containers, we are running the Postgres database, and if we check the memory, it consumes 79 megabytes. Let's switch back to the virtual machine scenario. Now, if we have to do this 10 times for 10 different customers, we will need 10 virtual machines that will consume resources to start 10 new Ubuntu servers, for example. They can consume only to start the operating system up to 20 gigabits of RAM. In Docker, we could just start another 10 containers and the amount of memory used would be smaller because Docker does not require also 10 operating systems, in this case, to be started. Another advantage in using Docker is portability. Docker containers encapsulate everything an application needs to run: the code, the runtime, the system tools, libraries, frameworks into a single package. This means that a Docker container can run on any platform and cloud without requiring system-wide configurations. Another point is scalability and CI/CD integration, as Docker is ideal for microservice architecture due to ability to quickly scale up or down. It's also highly compatible with CI/CD workflows, as container can be created, shut down, and replicated at will. Now let's discuss a bit about the Docker architecture. So Docker follows a client-server architecture. The Docker client communicates with the Docker daemon, which builds, runs, and manages Docker containers. The Docker client and Docker daemon can run on the same system, or the client can connect to a remote Docker daemon. The communication between the Docker client and the daemon can happen over Unix sockets or a network interface. Docker has multiple objects, it has images. They are a read-only template with instructions for creating Docker containers. They are built from a set of instructions specified in a Docker file. Each instruction in a Docker file results in a new layer that contributes to the final image. If you change the Docker file and rebuild the image, only these layers which have changed are rebuilt, making the process efficient and fast. The containers are the runnable instances of Docker images. They can be created, started, stopped, moved, or deleted using Docker API or CLI commands. Containers can be connected to one or more networks, having storage attached, or even spawn a new image based on their current state. Volumes are used for persistent different or shared data among containers. Data volumes are separate from the default union file system and are designed to persist data independent of the container's lifecycle. Docker networking subsystem is pluggable using drivers. Several networks can be created and each can use a different driver. Registries. Docker uses registries to store and distribute Docker images. Docker Hub is a public registry managed by Docker Inc. You can also host your own registry using the Docker registry. In conclusion, Docker has become an essential tool in the modern DevOps toolkit with its powerful feature of containerization. It provides a robust, scalable, and efficient platform for developing, deploying, and running applications regardless of the underlying infrastructure.